So now let's resume class. So last week we discussed on ideal diode. Can you all hear me?
Yes, clear,
Yes,
clear.
we hear you.
Okay, thank you very much. So we discussed on ideal diode, of which we based our analysis on two mode of operation, that is the forward bias and the reverse bias. And we said for an ideal diode, when it is in forward bias, of course, we expect it to behave, to be conducting and behave like a short circuit. And when it's in reverse bias, we expect it to behave as an open circuit, and it will be an open circuit, yes. Then when in forward bias, the voltage drop for an ideal diode will be considered to be 0. It is an ideal diode. Then we said diode is said to be in forward bias when the positive terminal of the cell or battery is connected to the positive terminal of the diode, and the negative terminal of the battery is connected to the negative terminal of the diode. Then diode is said to be in forward bias. And in the case of reverse bias, when the positive terminal of the cell is connected to the negative terminal of the diode, and the negative terminal of the cell is connected to the positive terminal of the diode, then it's said to be in reverse bias. So all our analysis was based on ideal diode. Inshallah, today we will still continue with ideal diode. We are still continuing with ideal diode. But in this case, we are basing our analysis on two applications of an ideal diode. Last week we based it on rectification, right? But this week we are basing our analysis on another aspect of application of diode, which is as a logic gate, the OR gate and the AND gate. So now I will share my screen now. So now, as I said, we are basing our analysis today on the OR gate and the AND gate. Looking at this picture, these two pictures, A and B, can you see my screen?
Yes, yes.
Okay. Yes. Which one is OR and which one is AND? Is it A or B? Which one is OR gate? I want you to talk, please. Which one is OR gate? A or B?
A.
A is OR gate, while B is an AND gate. And of course, we all know how an OR gate operates, right? OR gate means that when, let's say we have two inputs, so the output should be A plus B. So, and for the AND gate, this one, for the logic circuit, when we have an AND gate, let's say we have two inputs, then the output should be the product of the two inputs. Now, in this case now, when we want to perform this analysis, this is what we will do. For the OR gate, please, it is important you can identify the circuit. It is very, very important. You should be able to identify the circuit, because identifying the circuit will help you along to solve the circuit correctly. We help you to identify which of the diode will be on and which of the diode will be off. The same thing is applicable for the AND gate. Now, for the OR gate, when you are dealing with OR gate, Before you can identify which diode will be on or which one will be off, you have to look at the voltage source attached to each of the diode. For the OR gate, you go by a voltage source of higher voltage source. You go for higher voltage source. That is the voltage source with higher potential. So the voltage source that is attached with higher potential, the diode that is attached to that voltage source will be the diode that will be on. For the case of AND gate, the voltage source, you go with the smaller voltage source, the voltage source. That is the voltage source that is attached to the diode. The small value of the voltage source that is attached to the diode will be the one. The diode attached to that voltage source will be the one that will be on. Now, I know some people during exam, they may face difficulty of identifying which one is OR gate and which one is AND gate. So because of that, I personally have one simple trick. One simple trick. What is the trick? The trick is when you want to solve this circuit, after looking most of the time, it is not all acceptable rules. Acceptable rules is for the OR gate, you look for higher potential, the diode attached to it will be on. And for the AND gate, the diode attached to the lowest value of the potential, that is the voltage source, will be on, while the other will be off. But for my case, this is just an int. So so far it works. All you need to do is just look at the diode that is closer to point. Just take KCL of this one. So the one that is enclosed most, like this one also, you can see that this is the most enclosed. So meaning that you will consider this one to be on, while this one is off. So here also you consider this diode D2 to be on, while you consider this one to be off. So now let's try to analyze the circuit. So if D2 is on and this one is off, this is already open circuit, and this one will be what? Short circuit. What will be the value of the voltage source from here? Of course, we expect that the 3 volt will be fed here. So the voltage source V will equal to 3 volts, because this diode will be replaced by wire. So to calculate the current that flows through the circuit, then we use I is equal to the 3 volts here minus 3 volts here divided by 2 kilo ohm. That will give you what? 6 divided by 2 kilo ohm, which is equals to 3 milliamps. Clear?
Yes.
Alhamdulillah. So the same thing is applicable to this one. If you want to solve this one, you also take, then you have to be very, very careful about the direction of current. The direction of current, I can give you the same question like this, and I will reverse the direction of current. If I reverse the direction of current from here, now let's say the current is moving like this. It means that you will subtract this one from this one divided by this one. Please take note. Like in this case now, the figure B, you can see that the current is flowing from the positive 3 volt here, supply, then flows across this circuit like this. It means that the current I will equal to the 3 positive terminal minus 1 volt divided by what? 2 kilo ohm. 3 minus 1 divided by 2 will give us 1 milliamp. What will now be the value of the voltage here? Can someone tell me what will be the value of voltage here?
3.
Voltage.
1 volt.
1 volt, because diode 2 will be shorted. So this is the solution now. From figure 3.2a, this implies that we assume D2 conducts while D1 is off. That is, D2 conducts while D1 is off. I think I've given you the reason why we choose that. So I will now be 3 minus 3 divided by 3 kilo ohms. 3 minus 3 divided by 2 kilo ohms. And that one gives us 3 milliamps. And the voltage, of course, will equal to plus 3 volts, because this one is replaced by wire. The voltage here will also be fed here. So this is the analysis. D1 off, D2 off. So this is open and this is shorted. Then you can calculate the value of the current and the voltage. The same thing is applicable to figure 3.2b. So we therefore assume this is an AND gate. So we assume that D1 conducts while D2 is off. That is, D1 conducts while D2 is what? Is off. So if D1 conducts, it will be replaced by a wire. While D2 is off, this will be open. Then we can find the flow of current. That is 3 minus 1 divided by 2. 3 minus 1 divided by 2 kilo. Then we have 1 milliamp. And the voltage attached to the diode that is on will be 1 volt. Please, is it clear?
I didn't understand how the voltage became 1.
Okay. The reason why the voltage is 1 volt is this. Looking at, can you see my screen?
Yes, yes.
You can see that 1 volt here is attached to the diode that is on. This one.
Okay.
You know, this is AND gate. So you go for smaller value of the source voltage. So it is the diode that will be on. So it will be replaced by wire. So this is the diode replaced by wire. And the output voltage is attached here. As you can see from here. The output voltage is here. So it means that the voltage here, this one will be replaced by wire, and the voltage here, the value of voltage here, 1 volt, will be fed here.
Oh, okay.
Clear, okay, alhamdulillah. So
I'm sorry, so we take the smallest value.
Yes, for the
not
AND
the
gate.
closest one.
Yes, for the AND gate, you take the smallest value of the voltage.
Okay.
And for the
OR
gate,
gate, we take the largest value.
exactly, the largest value of voltage.
Even
That
if
is,
it's not close.
what did you say?
Even if it's not close to the power source.
It doesn't matter. Even if it is not
okay.
close. That is the rules.
Okay, it's clear.
But most times, according to the question I've solved so far, most times for the OR gate, the largest value is always close to this point. That's the reason why I said just go by the closest value, closest loop here. Most times, but the rules, the general rules is for the OR gate, you go for higher potential, higher source voltage, and for the AND gate, you go for the lowest potential. So now, I believe this is clear, right? The two questions, clear?
Yes, yes, it's clear.
Okay, okay. Now, the next aspect we will discuss today is on how to draw waveform for a given circuit. We are still, don't forget, we are still considering ideal diode. We are still on ideal diode. You know, as I said earlier, we have two models. So we have ideal diode model and constant voltage drop model. So we are still considering ideal diode. Now we have like from figure A to F here, we want to draw the output waveform for this circuit. We want to draw the output waveform for this circuit. Please, it is very important you listen to this procedure so that you will not mix the waveform. So if I will ask you this question, you will be asked, I will draw a circuit like this, any of these circuits. Let's say I draw this one, the first one. So you will be asked to draw the output waveform from this circuit. The next thing is calculate the positive and negative peak values of the output voltage. The positive and negative peak value. You have to write out the positive and negative peak cycle. So these are the two things you will write out. But in order to solve this one, you have to follow these simple steps. These simple steps. One, you will consider this diode. You will assume that the positive terminal of the input voltage is attached to this positive terminal of diode. And the negative terminal of this diode is connected to the negative terminal of the cell. What simply means is you consider this diode to be forward, and you also consider it to be reverse. Are you getting it now? If you consider the diode to be forward biased, then it means that this diode will be short circuit. And the output supply, that is the peak value, in this case is 10 volts. The peak value of the supply will be fed at the output. It means that for the positive cycle of this, for the positive cycle, when this diode is in forward bias, that is when you connect the positive terminal of the cell to the positive terminal of the diode, and the negative terminal of the cell to the negative terminal of the diode, we experience an output waveform that gave us the peak value of 10 volts. That is, the waveform will look like this. The waveform will look like this. Let me show you the output wave, like this one. We have something like this. That is the peak value. You have to write it out. If you did not write it out during your quiz or your test, I will not give you mark for this. After plotting this one now, the positive terminal, you can see positive terminal of this is attached to the positive terminal of this, while the negative terminal is connected to the negative terminal of the diode. Then in this case, this one is conducting, this one is conducting. Then the output waveform will do like this. From the question, the peak value is given to be 10 volts. You will now reverse the supply now. You can see. Now I reverse the supply so that the diode will be in reverse bias. Are you getting it now?
Can you replay it again, please? I didn't understand it, how we reverse and we got 0.
Okay. Let me explain. I said you have to follow some steps. The first one, connect the positive terminal of the cell to the diode here. That is, for the positive cycle, you assume the diode 1 is forward bias. If it is forward bias, you know this one will be shorted. Sorry, Yes, it will be shorted, replaced by wire, right? Then the value of the supply here will be fed at the output here, which will be positive 10 volts. That's the reason why you have positive here, 10 volts from here.
Okay.
Okay. Now, for the second step now, you have to reverse the direction of the diode. You can either reverse the direction of the diode, you can bring this negative, connect to the positive here, or you reverse the direction of the supply. You connect the negative terminal of the cell to the positive terminal of the diode, and the positive terminal of the cell to the negative terminal of the diode, such that this diode will now be in reverse bias from here. D1 in reverse bias. So when D1 is in reverse bias, what will happen to this one?
It will be open circuit.
It will be open circuit. It means that the voltage here cannot travel through this one, because this is already cut. You already opened this place. So in this case, the output peak will be 0. You will not see any output. So that's the reason why I said for the negative cycle, the value of the voltage is 0 volts.
Okay, I understand.
Okay, now you will now combine the two waveform. Now, if you combine the two, this is the positive, this is negative, this is positive, and this is negative. Is it clear now?
Yes.
Okay, alhamdulillah. So that is the solution for the first one. Now, in my quiz, if I give you quiz, please don't just jump to your answer. You have to follow the steps very well, because each step will let me know that, okay, this guy, these people, these students, they understand what they are doing. You must follow it like this, because each steps will carry mark. Are you getting it now? Now I have given you the steps to follow. Inshallah, I will upload all these lecture for the first class and the second class. I will upload it on my YouTube. Then I will send you the link. I will send you the link. I will send you the link on your email, so that some people are late, because I accepted some people lately, so they can go through it, so that you will not have any excuse that I was late because of that. I didn't know that you said that we should follow these steps. Always follow these steps, please, so that you will not lose any mark. So that is question A. Now going to question B, looking at this one. Now I want someone to analyze this circuit for me. I will call your name. I will call your name, because I have some late comer here. Among those that submitted their assignment last week, very late, so I will call them now. So Sulaiman and Roman, are you online? Sulaiman?
Yes, sir. Yes,
You are
I'm
online.
online.
Okay. I want you to analyze this circuit for me. Please explain. Let other people hear you. Bismillah.
Is it like the last one?
This one, yes. Draw the output waveform. Look at this question. In each of the IV diode circuits shown in this figure, V input is 1 kilohertz, 10 volt peak sine wave. Sketch. Oh, time off. Hello?
Yes, yes.
Now, please, this section we close now. No, it's remaining 9 minutes. Okay, we can proceed. Before it closing, maybe we will finish, inshallah. So now, quickly explain this one before this section closes.
The best to my knowledge, it's like the last one, right?
Yes, exactly. Just explain the way I explain now. Assume you are the teacher now. You want to explain to your colleague now, your friend.
Well, I'm not a good teacher, so
Just try your best.
D1 like the negative and D2 is for the positive or what?
Just explain. Explain from the supply that you will connect positive terminal first. Can you hear me? Hello?
Yes, Doctor, we hear you. We hear you.
Yeah, I hear you.
Yes, continue. I want you to explain, please.
Well, I'm not very sure صراحة دكتور.
Just say anything. Say anything. I want you to understand. That's the reason why I call you. Just explain. Faddal ya akhi. Not clear? Okay, okay. Don't worry. I want another person to explain, please. Who will volunteer? I want you to bail Sulaiman.
Yes, me, Doctor.
Okay. Faddal.
It will be open circuit. Same the last example.
Okay, it will be open circuit when you connect the positive terminal to this one.
The positive terminal with the negative terminal with the cathode.
Okay, then the output waveform will look like what?
Zero, still zero.
Okay, for the
not changing.
For the other cycle.
If we flip it to the positive,
okay,
we will get a big wave.
Good, very good. Let me show you the solution straightforward. So your friend has helped you. You can see now exactly what my friend, I did not notice your name, please. So exactly what he said now. So you connect the positive terminal to this one. And looking at this one, positive to negative, negative to positive. Which mode of operation is this diode? Reverse bias. Correct?
Yes.
Good. It means that this one will be what? Open. If this one is open, it means that this branch or this one cut off from this. So no output will be felt. You will not see anything from the output. It means that the output will be zero. That's the reason why you have straight line here. So it means that the positive peak will be 0 volt. So now for the negative cycle, sorry, don't mind this one. This one should be positive. I'm sorry. This one should be positive. It's a mistake. So for the negative one now, if negative is connected to negative and positive, this is positive, please. This is positive. Positive is connected to the positive. It means that this one is what? Forward bias for the negative supply. Then the output, this one, all this one will be replaced by what? Short circuit, that is wire. So meaning that the negative supply, yes, minus 10 volt peak will be fed at the output. That is why you have negative here. As you can see, everything on top here is positive, while here is what? Negative. Then you have negative supply here. Is it clear?
Yes.
Yes.
So now, see, some people are just joining now, wallahi. And we are almost done with the class remains just 7 minutes. Someone just joined now. This is problem, wallahi. This is problem, big problem. Maybe this is what I will be doing now. At the beginning of the class, if you did not join class after 5 minutes, I will take attendance. Then at the end of the class, I will still take another attendance. Because wallahi, it is not a good habit for you to join the class just 5 minutes to the end of the class. Wallahi, it's not a good habit. I am not okay with it at all. Someone just join now. And if I did not accept that person, he will claim that I did not accept him. He will just do the screenshot. Someone did it last week. He did the screenshot that he was trying to join and I did not accept him. Wallahi, this is problem. This is
Doctor.
big problem. You wanted to say something?
Yes, doctor. It's disconnected, and I tried to reconnect, and I joined. I'm joined from the beginning. Just disconnected and go again.
Okay, no problem. So this is what I will be doing. I will be taking attendance 5 minutes after the class, the opening of the class, and at the end of the class. This is what we will be doing now, inshallah. So that it will not be like some people, they will come at the end and be claiming that they are present. Please. Okay, now the next thing is what? Is to join the two waveform now. As you can see, 0 minus 10 volts, 0 minus 10 volts. Please, is it clear?
Yes, clear.
Any question,
Yes.
please?
Yes, I have one.
Okay. Go ahead. Please.
Can't we just change the position of the diode in the last?
Yes, you can change the position.
We can do it and make it plus 10 volt instead of changing the power source.
You said it will make it plus 10 volts?
Yeah.
No, it cannot be plus 10.
No. If we change the diodes and make it in the positive terminal instead of the minus terminal.
This is what you will be doing. What you said, I understand what you said. You said if you change, instead of changing the supply, right?
Yes.
Then you change this one.
Yes, exactly.
And here you also change this one again, right? Hello?
Yes.
The thing
Exactly.
is, the procedure is you consider the diode to be in forward bias, right? And
yes, exactly.
what we can do to make this one forward bias, because it's like you already connected the diode like this. The diode is already connected. We only need to flip the supply.
Oh, okay.
Only need to flip the supply to make it forward and to make it reverse. Just stick to this, please.
Okay, clear.
Okay. So I'm trying to take attendance now, please. Okay, no problem. Stop recording. Already stopped? Okay.